Alright, so now we have number 24. So the function is continuous and differentiable. So keywords, continuous, differentiable on the entire interval now tells me that EVT has to be true, MVT has to be true, and the very first one, IVT, all have to be true, such that f of negative 5, so when they give me points, I actually just graph it out. F of negative 5 is negative 10. F of 5 is positive 10. Alright, so all they did was give me 2 points. So now we have to decide if this is true, sometimes true, or false. F is an even function. Well, let's talk about what even means. Symmetry about the y-axis, which definitely is not the case. Better question would be, is f an odd function? An odd function would be symmetry around the origin, and actually if you just look at those 2 points, this function is symmetric. Well, it's not even a function, but these points are symmetric about the origin, which actually means it's odd. But if I graph it some way, let's say like that, now you can see that this is not an odd function. Just so you understand what odd means, you would turn the graph upside down and it still should look exactly the same. This is not an odd function. Alright, letter B, f of 0 equals 0. So are we guaranteed that that blue point will be on any graph that I create from negative 5 to 5 that is continuous and differentiable? Differentiable means no corner, cusp, vertical tangent. Continuous means no discontinuities, so I can't ever lift my pen. So I can easily make a function that does not go through the origin. So this one is, let's see, I should be writing true or false. So letter A is completely false. Letter B is sometimes true because the green graph that I draw will go through the origin. So I can draw one that isn't going through and one that is, therefore it's sometimes. Letter C asks, f prime of C equals 0 for some C between negative 10 to 10. So what's kind of odd is that they use negative 10 to 10. I do believe that it's kind of interesting, but the C values are your X values. Well, this graph only exists from negative 5 to 5. So that's one thing. So it can't always be true. Secondly, if we're looking at f prime of C being 0, we're going to look for horizontal tangents. So could I potentially have a horizontal tangent somewhere between negative 10 to 10 domain? Yes, the blue graph has a horizontal tangent. Put it right about here. But the green graph doesn't. So this one I would give a sometimes. The whole domain thing is kind of weird. The answer key might even say that it's always false because of that, but I would say that it's sometimes true. Letter D. F prime of C is greater than 0 between the x's of negative 5 to 5. Well, in this case, that just means that the graph is increasing. So this means increasing. Does the graph increase? Yes. Both my blue and green graphs both increase. Do they always increase, meaning the derivative is always positive? No, my blue graph decreases. So this is a sometimes. Letter E says from negative 10 to 10, given the y values, so this f of x means y values, the y values go from negative 10 to 10 for all the values of x between negative 5 and 5. So easier way to say that is that every single y value is always between negative 10 to 10. It's tricky because it kind of seems like it's talking about IVT, but what's tricky about it is if you look at my pink graph, I can create a graph whose y values go outside of negative 10 to 10, but if you look at my blue and green graph, they stay between negative 10 and 10, so this is also a sometimes. Letter F. F prime of C equals 0 for one value, at least one value. Well, the green graph, it's false, but the blue and pink graphs is true, so this is another sometimes. Letter G. F prime of C is equal to 2. So 2 is an interesting number. Now 0 was easy. 2, I have a feeling they're probably using MVT because they're asking me to guarantee a slope value, and it seems like a weird random number. So MVT says if your continuous close, differentiable in the open, then I can take the endpoint slopes. So I'm doing a slope from -5 comma -10 until 5 comma +10. So 10 minus -10 all over 5 minus -5. And yes, the slope there is 2. So MVT will guarantee this always. So that would be a completely true statement for letter G because of MVT. Letter H, f of c equals 9 for at least one c between -5 and 5. So this one is actually checking for IVT. Now remember, the points that were given gave you y values from -10 to 10. IVT will now guarantee every y value from -10 to 10 within the domain of -5 to 5. So this is always true. Graphically, it means there's no possible way for me to graph a continuous differentiable function without going through the y value of 9. And that should make sense to you. All right. Last question in the review, 25, complete the following without the use of a calculator. So we're going to be doing particle motion, and they're going to ask us a lot of questions. So I'm going to move this over, and let's start with letter A, write a velocity function. So velocity would be the first derivative, 3t squared minus 12t plus 9. When is the particle at rest? So if I want to do at rest, I would set the derivative equal to 0. And if I'm going to do that, let me factor out a 3. Set equal to 0. The factors would be t minus 3, t minus 1 equals 0, t equals 3, and t equals 1. So the definition of resting would be where the velocity is 0. Then they're asking me moving left and right. So here's my velocity sign chart. We always start only from 0 for a velocity sign chart. This is a parabola facing up. So here's what it would look like. Therefore, the signs would be plus, minus, plus. And so I am stopped at t equal to 1 and 3. I'm moving forward from 0 to 1, union with 3 to infinity. I'm moving backwards from positive 1 until 3. If they ask me why, I got to give my reasons. V of t is positive. Here, V of t is negative. And here, V of t equals 0. All right, letter C. What's the speed of the particle at time equal to 2? So C, speed at 2 would be the same as the absolute value of the velocity at 2. So the velocity at 2 would be, so 9, so let's see, absolute value of 12 minus 24 plus 9. So negative 12 plus 9, which would be negative 3, but absolute value would give me a speed of 3. Letter D, write the expression for the acceleration. So letter D, the acceleration, I would use this equation of velocity, not the simplified version. So acceleration would be the derivative, 6t minus 12. I can factor out a 6, and I'll get 6t minus 2. Let's see. That is as far as I need to go. So there's my acceleration. What is the minimum velocity of the particle? So I'm actually going to take this to a new page so we can finish the question. All right. So now it wants to ask letter E asked me the minimum velocity. If I want a minimum velocity, I would take velocity's derivative, which is the same as acceleration, which we just got a second ago, set it equal to 0 or undefined, which doesn't happen in this case. Minimum velocity from 0 to 3 would be 0 to 3, 2. So 0. This is a line sloping upward, so it looks like that. So this would be negative, this would be positive. Here is a minimum. This is down, back up. So this is a max, and so is this. So in answering letter E, what is the minimum velocity from 0 to 3? The minimum velocity would be v of 2, which would be that the velocity is 3t squared minus 12t plus 9, and then v of 2, I believe we found was negative 3, I believe, from before. Letter F asked me what's the maximum. So letter F, the possible maximums happen at t equal to 0 and t equal to 3. If I want to find the maximum velocity, I would have to find the velocity at 0, compare the two, and 3, and compare the two values to see which one is bigger. So the velocity at 0 would be 9. The velocity at 3 would be 27 minus 36 plus 9. And in that case, 27 minus 36 equals 0. So the maximum velocity happens at t equal to 0. Hopefully I did my math right. Sometimes I make really dumb mistakes. Letter G. Is a particle moving towards or away from the origin at time equal to 2? So let's think about this. Here's the origin. If I have a man standing here to the right of the origin, meaning his position is a positive value. If I want to move towards the origin, I'd be moving backwards. But if I'm behind the origin, meaning my position is a negative number, if my velocity is negative, now I'm moving away from the origin. So we got to make sense of this. The only way that I would know which way I'm going, towards or away from the origin, is if, number 1, I knew where I was standing at time equal to 2. And then if I knew which way I was walking at time equal to 2. So the position at time equal to 2, I just need to know if it's positive or negative. So we get 8 minus 24 plus 18 plus 2. So that's 20, negative 4. So this becomes a positive number. So I am the blue man standing to the right of the origin. The velocity at 2 was negative 3. So I'm walking backwards, not forward. So therefore I am moving towards the origin. Okay, so things that aren't on here that I would remember: speed, to find a maximum, not a maximum, to find if you're speeding up or slowing down. Speed, you need to know your velocity and your acceleration. If both of them are the same sign, you would be speeding up. If they're opposite signs, you'd be slowing down. A new question, letter G, that you haven't necessarily answered before is if you're moving towards the origin or away from the origin. We know if you're moving towards or away if you know the position. So if you're to the right of the origin or to the left of the origin, and then you also know which way you're moving, which would be velocity. So to answer letter G, you needed to know the position at time equal to 2 and then the velocity at time equal to 2. And that's how you figured out if you were going towards or away from the origin.